good morning. So now we discuss next topic, that is the difficulty of classification. See, we define an object as something that has a crisply defined boundaries. However, the boundaries that distinguish one object from the another are quite fuzzy. It will be different from one object to the another object. Okay, an intelligent classification is difficult since there are the parallel to same problems in object-oriented design. For example, see, look at your leg. Where does your knee begin and where does it end? So we don't know. So how it will be start and how it will be end. And design of word processing system and the classification of biology and the classification of chemistry, and depending on the kind of bonding present in the chemical substances, the substances may be classified as ionic and molecular and metallic. So it will be, the object will be different to one to another. So we cannot identify. So how it will be created, how it will be ending that one. Okay, like this we have given some of the differences. See examples. Look at your leg. Where does the knee begin and where it end? And design of word processing system, classification biology and classification chemistry, and depending on the kind of bonding present in the chemical substances, the substances may be classified as ionic and molecular metallics. Okay, likewise we have to say it will be different from to another. Next, the incremental and iterative nature of classifications. Intelligent classification is intellectually hard work, and that it is best comes about through an incremental and iterative process. So the intelligent classification is the hard work. When it will becomes the perfect processing is based upon the incremental and iterative process. Next, the incremental and iterative nature of the classification directly impact the construction of a class and object hierarchies in the design of a complex software system. So there is no perfect classification, although certainly some classifications are better than others. So intelligent classifications requires a tremendous amount of the creative insight, and any classification is relative to the perspective of the observer doing the classification systems. Okay, so likewise you have to say that it will be different to the from one to another. So whenever the using for the incremental and iterative nature of the classification is the best thing for the, we can assign to the classification of the particular systems. Next, identifying the class and object, that is a classical and modern approaches. See, historically there are only three general approaches to the classification. The first one is the classical categorization, second one conceptual clustering, third one prototype theory. These are the three types of modern approaches. The first one is the classification approaches like categorization, second one conceptual clustering, and third one prototype theory. See, classical categorization, all the entries that have a given property or collection of properties in common from a category, such properties are necessary and sufficient to define the category. So in the some of the entities are, we have given the properties or collection of properties are common from the categories. So in that categories is separate, it's common, it may be necessary and sufficient to define the particular categories. Okay. Then specifically one can divide object into disjoint sets depending upon this presence or absences of particular properties. So we can divide the different objects to the based upon the presences. In general sense, properties may denote more than just measurable characteristics. They may also encompass and observable behaviors. Okay, the properties may denote more than just measurable based upon the measurable characteristics, and that the particular properties that should be considered in a given situations are highly domain specific. It may be highly domain specific based upon the situations. See, the problem domain here can assign A, B, C, D. So different of applications are defined. Okay, based upon these diagrams we can assign which is the object is be perfect, which is the based upon the situations. Okay. Next, conceptual clustering, that is in this approach classes are generated by first formulating conceptual descriptions of these classes and then classifying the entities according to the descriptions. So based upon the description of these classes, we can classify the different of entities from the based upon the situations. And the prototype theory, a class of object is represented by a prototypical object. So it will be represented in the prototypical objects, and an object is considered to be a member of this class if and only if it resembles this prototype in significant ways. It will be defined to the different of the significant ways. Next, object-oriented analysis. The boundaries between analysis and design are fuzzy, although the focus each of the quite distinct. So everything will be distinct. In analysis, we model the system by discovering the classes and objects that form the vocabulary to the problem domain. Okay, and in design we invent the abstractions and mechanisms that provide the behavior that this model requires. In approaches of object-oriented analysis, different type of approaches are there. The first one is the classical and modern approaches, behavior analysis, domain analysis, use case analysis, CRC card like class responsibility collaboration cards, informal English descriptions, and structured analysis. These are the different type of approaches from the object-oriented analysis. These are the classical and modern, behavior, domain, use case, CRC, that is the class responsibilities and classification, and informal English description and structured analysis. These are the approach of the object-oriented analysis. Next, classical approaches. It is derived primarily from the principles of classical categorization. So it will be based upon the different of principles. See, Schleyer and Miller suggest the candidate classes and objects usually come from one of the following sources. It will come from to the based upon the different type of sources. The first one, tangible things, roles, events, and interactions. See, what are the tangible things? That means of cars and telemetry data and pressure sensor. These are the tangible things. Roles are the mother, teacher, and politician. Events, landing, interrupt, and request. And interactions means both loan, meeting, intersections. So last class we have to discuss the different type of cars, temporary telemetry data, and pressure sensor. So here, what are the roles and the events? What are the interactions? The banking interaction go from the loan, the meeting from the meeting, interaction to the customer. Likewise, we can assign to the different type of the classes and objects. See, tangible things, roles, events, and interactions come from the different type of sources. From the perspective of database modeling, rows offer a similar list with peoples, places, things, organizations, concepts, events. See, peoples, humans who carry out some functions, areas set aside for people or thing. That is, humans who carry out some function. That is the people, and places, areas set aside from people who are things, and things, physical object or group of objects that are tangible. And organization, see, formally organized collection of people. That means of organized mean it is a collection of people. Resource, facilities, and capabilities having a defined mission whose existence is largely independent of the individuals. And what are the concepts means? That is the principles or ideas used to organize or keep track of business activities and the communications. So the concept means we can implement the different principles, ideas to using in the organization and keep track of business activities and the communications. And next one is the event, things that happen usually to something else at a given date and time or as steps in an ordered sequences. So these are the preferred to the like rows offer a similar list as the people, places, things, organizations, concept, and events. Okay. Next, code and Udon suggest at another set of sources of potential objects. First one is structure, other systems, devices, events remembered, role played, locations, organizational units. Okay. So structure, that is a is, are, and part of relationships. Okay, that is the generalization and aggregation is the relation from the structure. That is the structure is a and part of relationships. So EJ means generalization, part of means the aggregation relationships. And other system, that is the external systems with which the applications interact. That is, which applications are interact with the externally, that is called as the other systems. Okay, there is external systems with which the application interacts. Next one is devices. Devices with which the application interact. That is the which applications are interact with the particular device. That is called as the devices. Okay. So devices with which the application interacts. Next, events. Remember, there is an historical event that must be recorded. So some of the historical records has to be historical events has to be recorded. Okay, and roles played. There is different roles user play in the interacting with the application. So different roles are available in the particular applications. For example, we can implement any one of the application. It may be different roles. So one of these requirement section, one is the analysis, one is the design, one is the coding, one is the implementation, one is the deployment. So likewise, the people are define the different of so perform to the different of roles in the particular applications. Okay, and the location, that is the based upon the physical location, offices and site important to the application. So based upon the application, it will be using for the physical locations or maybe offices or sites are important to the application. So based upon application, we can assign the location. It may be work from home or offices and other sites based upon the application. And organization units, group to which user belongs. So organization which users are to belong to the particular group. So these are the some of the potential objects suggested from the code and U-bound. That is the structure, other system, devices, events remembered, roles played, locations, organizational units. Okay. Next one. So behavior analysis, that is the dynamic behavior also be one of the primary source of analysis of classes and objects. So what we say, the dynamic behavior is one of the primary source of the classes and objects. So for example, we group things that have common responsibilities and from hierarchies of classes involving superclasses that embody general possibility responsibilities and subclasses that specialize their behavior. So simply we can use from the inheritance concept, that is the one of the superclass and subclasses. It may be transferred to all the operations to perform the subclasses. It's based upon the situation. See, we group things that have common responsibilities and from hierarchies of classes involving superclasses that embody general responsibilities and subclasses that specialize their behavior. Okay. And next one, Rubin and Goldberg offer an approach to identifying classes and objects derived from the system functions. So we can use some of the approaches to from the classes and objects derived from a system from the approaches. This is called as the behavior analysis. Okay. Next one is the domain analysis. So domain analysis seeks to identify the classes and objects that are common to all the applications within given your domain. So based upon domain, these are the different type of classes and objects may be common to the different of applications such as patient recording, bond trading, compiler or missile version. See, in these examples, some of the applications are common to the particular domain. Simple, for example, student login ID, like there is username and password, and the same application will be common to the library management. Likewise, we can use some of the applications will be common. It will be easy to for implement of the particular classes and objects. See, domain analysis seeks to identify the classes and objects that are common to all applications within a given domain, such as patient record tracking, bond trading, compilers or missile avionics systems. So these are the applications. Some of the applications are common to the particular systems. Okay. Then the next one, domain analysis is defined as an attempt to identify the objects, operations and relationships that are important to particular domains. Okay. And next one, Murray and Bailin suggest the following steps in domain analysis. Construct a straw man generic model of the domain by consulting with the domain experts. So we can implement the general things. It may be based upon the domain experts, and examine the existing system within the domain and represent this understanding as common format. So what we do, what are the existing systems in the existing system, what domains we have implemented, that domains we have to understand, that will be easy to implement the proposal systems. It may be useful to the proposal system to implement of the particular systems. Okay. Next one, identify the similarities and differences between the systems by consulting with the domain experts. Okay. So we have to consulting with the domain experts. So what are the similarities, what are the difference between the systems to system and implement like existing and proposed systems. And next one, refine the generic model to accommodate the existing systems. So we have different type of models to accommodate the existing system. See, domain analysis may be applied across similar applications, that is the vertical domain analysis, as well as to related to parts of the same application, that is horizontal domain applications like domain analysis. Okay. The next one, use case analysis. So use case analysis can be coupled with all three earlier approaches to the derive from the process of analysis in the meaningful way. So based upon these before approaches, we can use from coupled from the all the things and apply to the use case analysis. And Jacobson defines a use case a particular form or pattern or exemplar of usage, a scenario that begins with some user of the systems initiating some transaction or sequence of interrelated events. Okay, and we can apply use case analysis as early as requirement analysis, at which time and end users and other domain experts and the domain and the development team enumerate the scenarios that are fundamental to the system's operation. When we can implement, when we can apply the use case analysis, when before we have to identify what are the requirement analysis going on, what are the time, which time we have to use it, and who are the domain experts, what are the development team will be involved in the particular scenarios and the particular systems. So okay, if these are things we can identify, then we can go for the use case analysis. And these scenarios collectively describe the system functions of the applications as the applications. Okay, as the team walks through each scenario, they must identify the object that participate in the scenario. So first of all, they have to identify which objects are participate in the particular systems, and that the participate in the scenario that lays the responsibilities of each object and how the object has to be cooperate from the other objects. So first we have to identify what is the objects will be there, and what the objects will be, how to interact with the particular system, what are the responsibilities of the particular system, and how the objects are collaborative with one to another objects in terms of the cooperation, in terms of the operations each invoke upon the other operations. So likewise we have to analysis of the use cases. Okay. Next one. A use case analysis is the primary form from the gathering usage of requirement for a new software program or task to be completed. The most important to the use case analysis to implement of the new software programs are the particular task has to be completed. Next one, the primary goals of use case analysis are designing a system from the user's perspective, communicating system behavior in the user's terms, and specifying all externally visible behaviors. And another set of goals for a use case analysis is to clearly communicate, that is the system requirements, how the system is to be used, what are the roles will be played in the particular system, what the system does in the response to the particular stimulus, and what the user receives from the system, and what values the customer or user will receive from the particular system. So likewise we have to identify what are the goals will be available, what are the use cases will be used in that one, so what are the system requirements, how the system will be used, how the system will be played in the particular operations, what is the process will be going on, how the user will receive the particular system. So everything will be you can identify on the use case analysis. Okay. And next one, CRC, that is a class responsibility collaboration card. That is, CRC card has been emerged as simple yet marvelously effective way to analyze the scenario. It is the most important to analyze the scenarios. Okay, and the CRC card is nothing more than 3x5 index card, and upon which the analysis writes in pencil the name of the class, its responsibilities, and its collaborator of the other. See, this is the 3x5 class. That is the one of the top of the card is the pencil, and half of the card responsibility, and half of the other card is the collaboration. So here we have to define three parts. That is, the first one is the name of the class, and next one is the responsibilities, and next one the collaborators. And one card is created for each class identified as relevant of the scenario. In every class we can create to the one CRC card, because of we can identify the particular scenarios. Okay, and CRC cards can be spatially arranged to represent patterns of collaborations. Next one, as viewed from the dynamic semantics of the scenario, the cards are arranged to show the flow of messages among the prototypical instance of each classes. See, whenever you have to dynamically assign, we can assign the different type of messages from the flowing, that is the active, like a sequence diagram likewise, we can assign the flow of messages, but that will be easy to identify what the process will be going on between the objects, okay, or between the classes. Next, as viewed from the static semantic of the scenario, the chords are arranged to represent generalization, special, or aggregation hierarchy among the classes. So whenever we have to assign the classes, we can use a different type of relationship, that is maybe generalization or specialization or aggregation, based upon the hierarchical among the classes. Whenever we have to arrange the hierarchical order, in that order we can use the different relations, that is the generalization or specialization or aggregation hierarchy to the different type of classes. In that way, you can say that is the CRC are the most important in particular to identify the classes. Next one, that is informal English description, that is a radical alternative to classical object-oriented analysis was first proposed about, and who suggested writing an English description of the problem. So we can write a perfect English to a particular description of a problem, and then underline what are the nouns and verbs in the particular systems. The nouns represents the candidate objects and the verbs represent the candidate operations upon them. So here you can assign the two parts, that is the nouns and verbs, and the nouns will be the candidate objects and verbs defined the candidate operations. Okay, it is simple and it forces the developers to work in the vocabulary of the particular space. Whenever it will be assigned nouns and pronouns as a particular English, it will be easy to developer to work in the vocabulary from the problem spaces. Okay, in that way we can say that informal English dictation is the most important for the particular applications. Next, structured analysis, a second alternative to classical object-oriented analysis, uses the product of structured analysis as a front end to the object-oriented design. It is one of the alternative classical object system. Okay. Next one, in this approach, we start an essential process of the system that describe to the by data flow diagrams and the other product of structure analysis. From this model, we may proceed to identify the meaningful classes and objects in our problem domain in there are three different ways. First one is the analyzing the context diagrams. So we can first analyze what are the context diagrams with the list of input or output data elements. Think about what they tell you or what they describe. So it will be doing the what they tell and what we have to discuss the particular systems. See, and the second one, the next two techniques involve analyzing the individual data flow diagrams. Data flow diagrams are most important to what is the process is going on between the objects. What is the data will be flow to the particular operations. What are the database we can use the particular systems. And next one is the given particular data flow diagram, candidates objects may be derived from the following. That is the external entities, data stores, control stores, and control transformation. These are the four things: external entities, data stores, control transformations. Okay, and candidate classes derive from two sources, that is the data flow and control flow. This is the most important from the data flows and control flows. Next, Sedgwick and Stark suggest another technique which they cause abstraction analysis. This next one, so Sedgwick and Stark suggest another thing is the abstraction analysis. So the abstraction analysis focus upon the identification of central entities and which are the similar in nature to transform in the structure design. So it will be analyze the what are the entities are identified. So what entities we can identify, what are the entities focus on particular system and which are the similar to the particular system. So in the structure design we can analyze based upon the abstraction analysis. Okay. Next one, identifying the key abstractions. That is the finding of key abstractions is a key abstraction is a class or object that forms part of the vocabulary of the particular problem domain. The key abstractions are the mainly class and object. It is the part of the particular problem domain. And the primary value of identifying such abstractions is that they give boundaries to our problem. So first of all, we give the boundaries of the particular problems. Okay. And they highlight the things that are in the place system and therefore relevant to our design and suppresses the things that are outside of the system. The identification of key abstractions involves two processes, and the first one is the discovery and inventions. Through discovery, we come to recognize abstractions used by the domain experts. Okay, through the invention, we create new classes and objects that are not necessarily part of the problem domain but are useful to the artifacts in the design of the implementation. So likewise, we have to use the different type of key abstractions. The main abstractions are class and objects to identify what are the classes we can use, what are the abstractions, what are the discovery and invention is there, what are the experts are using from the domain experts. Through invention, we have to create the new classes and objects that are not necessarily part of the problem domain, but are useful to the artifacts and design of the implementations. Okay. Okay, thank you.